Your windows are not your biggest moisture problem. They're just the one the house decided to show you. Most of us have seen it. A cold morning in January, condensation running down the inside of the glass, maybe frost building up at the corners. And the instinct is bad windows. Time to replace them. But here's what the building science actually shows us. That condensation formed because warm, moist air inside your house hit a cold surface. The window made it visible. The window is not the source. The same process, warm, moist air hitting a cold surface, is happening right now inside of your walls, your attic, your crawl space. Except there's no glass to make it visible. There's just wood, insulation, and time. Your windows are showing you something. Your walls are hiding the same thing. Moisture doesn't stay where you put it. It moves. It follows temperature gradients, pressure differences, and air movement. Warm air carries more moisture than cold air. That's not an opinion. That's physics. When that warm, moist air finds a cold surface anywhere in the building assembly, it gives up that moisture. Condensation forms. And if that surface is inside your wall, behind your siding, on the underside of your roof sheeting, you won't see it. Not until it's been there long enough to grow mold, rot the framing, or compromise the assembly entirely. Think about what's inside an exterior wall. You have drywall on the inside, then insulation, then sheathing, and then whatever cladding's on the outside. Every one of those layers has a temperature. In winter, the inside is warm and the outside is cold, which means somewhere in the assembly, the temperature crosses the dew point. That's where the moisture lands. That's where the damage starts. Mold doesn't need much. The right temperature, a food source, and moisture. Your wall assembly has all three. And it can go on for years before anything visible on the surface you can actually see. The two places in the house that collect the most hidden moisture are the ones we never look at. The attic, because warm air rises and finds the coldest surface in the house, the underside of the roof sheeting, and the crawl space sits directly on the ground, which is a constant source of moisture. Most crawl spaces are poorly detailed. Vapor barriers installed without attention to seams, penetrations, or wall connections. They just breathe, pulling ground moisture up into the house continuously. Nobody hands you a diagram of your house showing you where moisture goes. You bought a house, not a building science education. And the industry that built the house wasn't required to think past the day of the final inspection. So the moisture has been moving through your building assembly since the day it was built. And the only signal you've been getting is the occasional stain, that musty smell that comes and goes, the window condensation in January that you've been blaming on the glass. So here's what to do with this. The window condensation is useful, not as a diagnosis, but as a signal that the moisture levels in your house are high enough to make it to the glass. That tells you the source is inside, not outside. High indoor humidity in winter means moisture is being generated inside of the house. Cooking, showers, breathing, sometimes the ground under a poorly sealed crawl space. That moisture just isn't leaving fast enough. The question isn't just, how do I stop condensation on the windows? The question is, where's the moisture coming from? Where else is it going? What surfaces is it landing on that I can't see? Because the fix for window condensation and the fix for moisture inside your wall assembly are not the same thing. Replacing the windows addresses the surface. It doesn't address the source. If the source is a moisture-saturated crawl space, pushing humid air through the house, your new windows will condense less, or stop condensing entirely. Not because the moisture problem is solved, but because you replaced your most visible signal with a higher performance surface. And it doesn't show that condensation anymore. You spent $15,000 and made the problem harder to see. Your windows showed you something this winter. The question worth asking is what else in the house is seeing the same thing and doesn't have the glass to show it to you? Building science explains it. Applied correctly, it fixes it.